We can start, I
Yep,
think.
let's
So,
go.
welcome to our new episode of podcast, of our Testing Minute podcast. Here, as always, I'm Alexander Romanov, software engineer in test in IoG.
And I'm Artem Rihorenko, QA coach.
Okay,
Cool.
good. And today we have a guest, and not just a guest, but very special guest, and his name is Rob Meaney, and he's going to talk a lot about one interesting thing that bothers many testers, I think. We are going to talk today about testability. So, hi, Rob.
Thank you so much. Thanks for having me and picking a subject that I've spent so many years talking about. So yeah, testability. So I was the testability guy for so long. Everybody was sick of hearing me talk about testability. They knew what I was going to say before I said it. So it's something that I've been so passionate about for many years. Primarily because it was one of the first eureka moments in my career that allowed me to see a hugely positive impact from relatively small changes. So there's not too many places in software product development that you can make small changes and have these enormously positive impacts. And testability was the first time I experienced that. The second time was probably operability. But that's a whole different podcast and conversation.
Okay.
But actually, what I've learned, what's really cool, and I had this conversation yesterday with a team of testers, is that when I think about testing, I think about risk. Testing is primarily focused around risk. And there's two components of risk. There's likelihood, okay? The likelihood of something happening, and the impact when it does, how bad the problem will be if it happens. And when I think about my career, there's two key levers that I use to manage risk. The first one is testability. So the easier it is and the faster we can test something, the more likely we are to detect problems. Is that fair to say? So we can increase the likelihood of detecting problems by increasing testability. Okay? So that's the first component of risk. And the second component of risk is impact. And when I talk about operability, and by testability, I mean the ease with which we can test the thing that we're testing, the software typically we're testing. With operability, which is the second component, it's the ease with which we can build, deploy, and operate the software in production. Okay? So if we think about impact, our operability allows us to minimize the impact when defects do get into production. So operability covers things like observability. How easy is it to observe and understand your software systems? It covers things like the controllability of your production system. How easy is it to put a feature behind a feature flag, blue-green deploys, maybe shadow deployments, all this kind of stuff. So you can put changes into production and detect if there's problems quickly, isolate it to a small number of people, and then things around the deployment pipelines that allow us to get fixes and changes into production really quickly before customers even notice. So by focusing on testability, you minimize the likelihood of introducing defects. And by focusing on operability, you minimize the impact of those defects when they inevitably do happen in production. So those two levers, testability and operability, are the key things that allow us to manage risk.
Okay. Actually, this is a good intro for general overview of testability and how it lays in terms of the risks. And actually, in mostly all of our episodes in our podcast, we start usually with terminology. So before we go further with testability, we need to share the knowledge about the term. What is exactly testability? Why it matters? And maybe who needs it? Like for roles, persons, whatever.
Right. Well, I'll start with the first question. So testability. For me, the simplest and most concise description of what testability is the degree of ease with which you can test something, right? Typically, we talk about software, right? So it's simply the ease with which you can do it, right? So if it takes you more time or effort to complete the same level of testing, it has a low level of testability.
Mm-hmm.
If, however, you can write, so testability has different components as well, right? So I like to think about testability from the perspectives of test automation and test exploration, let's say, because so typically if you talk to a developer about testability, they'll talk about, oh yeah, how easy it is to write unit tests, right? But that's a very narrow definition of testability. Testability, I've created a load of models around testability, but testability in a holistic sense is literally how easy is it to test your software, okay? Mm-hmm. And like, there's different variables that influence that, right? There's things like, I have a model I call the 10 T's of testability. So 10 P's, excuse me, of testability. And it goes through all the 10 variables that I see that influence our, the ease with which we can test. Like, we've got things about philosophy of a team. You know, if the team's philosophy is pretty shit and it's just like big lumps of code and throw it over the fence, testing is difficult. If people don't have adequate access to resources and training, testing is difficult, right? If, you talk about the architecture and the structure of the product, can make testing difficult. There's so many variables that can make testing difficult. And as I said, that's why I created that model called the 10 P's of testability, is because I talk through each of the 10 P's, which represent a different variable that can influence how difficult or easy it is to test your software. Not just in the very obvious sense of, the software has a really nice API or, really nice abstractions to test against. It's the environment, it's the people, it's the access to resources, it's the pressure. There's lots and lots and lots of things that influence our ability to do good testing.
Mm-hmm. So, as I understood for now, the view of testability is different depending on the particular person who is responsible for it, for testing or for testability as a, let's say, as a capability of the software. So for developers, it means mostly in the ease to write unit tests. For testers, is just how easy to test. What else? What about other people who are involved in software development?
Yeah, it's an interesting one, right? Because when you think about testability, right, ultimately the reason why testability is such an important thing to me is because people see testability as a testing problem. It's like, testers, it's difficult for them to do their job. It's a testing problem. But that's a very shallow or short-sighted view of these things, because when you can test things really quickly and really easily and find important problems quickly, everyone on the team benefits. The developer benefits because they get faster, better information regarding the types of bugs that have been introduced. The team lead will benefit. The product owner will benefit. The managers will benefit. Everyone benefits. So testability is an enabler of fast feedback. And fast feedback is what allows us to learn more quickly. And it's our ability to learn more quickly that allows us to be successful. So testability is something that empowers everyone in a software product development team to be more successful. And I had, to really amplify that message, one of the key experiences I had in my career was many years ago. It's about 10 or 15 years ago now. I started in a company that had decided we're going to start up a whole new software engineering department in Cork in Ireland, where I live. They hired 35 different people, from software developers, architects, documentation people, I was a test automation engineer at the time, testers, managers, all that stuff. 35 people in Cork. And they'd built a proof of concept piece of software over in the US, and they said, we have the proof of concept. We think we should build this build this out on a larger scale. Let's hire a whole department of people. So the first thing they did for these 35 people was to get us a regression test, the first release of this software product that they'd built. And we spent 7 weeks regression testing the software before we released it, right? And that wasn't just 7 weeks of 9 to 5. That was 7 weeks of late nights and weekends and everything. It was absolutely horrendous. And it was a really good thing, though, because everyone, all 35 did it. Managers, developers, testers, everyone. And a few days after we released the first release, the guy that we'd hired as the architect in the Cork office, he came to my desk, a guy called Alex, and he said, Rob, how can we design this stuff to make it easier to test? Because he was like, that was such a pain in my ass. That was 7 weeks from hell. I never want to endure that again. So what happened is we worked through it together, and we came up with a way of designing the software to make it easier to test. I have another model called the CODS model based on how we did that, right? But I won't go into that unless you want me to do that. And we redesigned how we built the software. And over the next 12 months, we managed to go from 7 weeks of 35 people regression testing to 2 days of like 1 or 2 people regression testing. And the impact on the testers was obviously significant, but on the developers was huge because they now had a really great suite of test automation that we could build, deploy, and get feedback in seconds and minutes. The impact on everyone across the team was so positive because we could now just consistently make changes safely, get fast feedback. The interesting thing as well, so we had the testers were happier, the developers were happier, the managers were happier. This customer support people were happier. Why were they happier? Because when we developed our system with testability in mind, it unlocked things that we never expected to happen, right? So previously, if a customer had encountered a problem on site, this was software that ran on customer specific hardware and on location, right? Before, it was a big problem in terms of trying to reproduce the issue because they had specific hardware running the software. So it would be really hard for us to reproduce that. We'd have to get the specific types of hard drives, network, switches, all the stuff. It was basically a cloud in the box solution with software running on top. Mm-hmm. But because the way we designed it, we could actually go onto their environment and actually do a raw dump of their data and inject it into a simulated version of their setup and reproduce their exact problem in like minutes. So we grab a JSON dump from their environment. This is because we designed it to be testable. We injected it into our version of it, recreated the interaction with the hardware via this JSON file, reproduced the bug. We could then fix it and verify that it was fixed in minutes and put the fix in place. Previously, this would have taken weeks. And this was taking us minutes to do now. Because the key there was that what we had done to enhance testability is we created a pattern for abstracting aware interaction with the hardware so that we could simulate the interactions. So when we talk to the hardware, we would do a dump of a JSON file that represent the interactions. And then we could put our software in read mode and inject the JSON to represent the simulated interaction with the hardware. And then we could modify the contents of that file to put it in any state we wanted. So now all of a sudden we'd removed our dependence on the hardware so that we could test, so that we could run automated tests that would consistently be, in a good state and all that kind of good stuff. What we didn't expect was that we could then use that same mechanism in our customer's environment to do a dump of their interaction with the hardware and inject it into our software locally to debug all the problems.
Yeah.
And it was just like, so the support engineers were just, their heads were blown. So there was these crazy side effects that we didn't expect for everyone in the team, from the developers, the testers, the managers, and then customer support and beyond. So it just had this outrageously positive impact from something that seemed quite small. So it was a really kind of eureka moment in my career. It's like, wow, this is the silver bullet. There's not supposed to be a silver bullet, but like, this is the silver bullet. But so it was really, really amazing experience that really opened my eyes to testability. And at that point, I went, right, everybody needs to know about testability. So that's why I started writing and speaking so much about testability, is because like that was like one of those experiences where you kind of go, everyone needs to know this. Why isn't everyone doing this? This is crazy. Look at the positive impact it's had.
Actually, it looked like you maybe wrote our notes because you just answered the question that I have, like how testability impacts the software development process. And here it is. Here is the story. How I can feel that it was a huge impact on it. But maybe you may discover more maybe specific stuff when you think about the stability and how it impacts the software development process?
There's loads of things. I could go on. Like, I'll give you an example. So my job at the moment is I'm senior director of engineering for a software company. So I don't work in testing anymore. I work in managing a whole department. And you might think, what the hell does testability how does that help you? When I want to work with a team, guess who the first person on the team I talk to if I want to debug the team? I talk to the tester. Yes. And I say to the tester, what kind of challenges or problems or pains do you encounter, which are signs of testability problems? Because what I've learned over the years is when a tester is experiencing pain and problems, it's symptomatic of systemic problems in the team. Because it probably means there's problems with the architecture. It probably means there's problems in terms of the team dynamics and how they communicate and interact. It may mean there's problems in how they slice their work into small pieces. The relationship a tester has with the product and the team is a key way of understanding where the problems are in that team. So it's a funny one. So that's a very interesting kind of technique I've started to use to debug teams is talk to the tester, understand what their experience is like, where the pain is. I've got loads of tickets here, nobody's helped me. Okay, so there's a dynamics problem. The team isn't working together to test. Or it could be like, I'm spending so much time trying to test this stuff, it's really hard to test. And I say, okay, maybe we've architectural issues. And that brings me on to a whole different thing, which is, and there's a lot of people smarter than me have spoken a lot about this, which is around the synergy between testability and good design and software. So there's people like Michael Feathers and people like Dave Farley and smart people like that, much, much smarter than me, that talk a lot about the relationship between testability and the quality of the design or architecture of your software. So when a software is hard to test, it's a very strong signal that the architecture or the design of your software is actually substandard. It's a sign that you've got poor abstractions in the software. And that's a really strong signal, again, that we need to be listening to, is like, if it's really hard to write the kinds of tests, whether it's test automation and unit integration or end-to-end level, whatever it is, it's a sign we've testability issues. If I'm struggling to test scenarios when I'm exploratory testing or whatever, again, it's a sign that there's probably something not quite right in terms of the architecture of the system. So we need to listen to those signals, and we need to talk to the developers and like whoever's architecting or designing the system, and start saying, this is a signal that we have a problem. But most people aren't aware of that relationship. They don't realize that testing pain is an indication of poor design. So that's another one that you might be interested in. Like, again, like if you find, like, there's some anti-patterns out there where you go to companies and they're like, we need to write more end-to-end test automation and more. It's like, if you have to write lots of end-to-end test automation, you have a problem in your architecture. Your architecture should facilitate testing as close as possible to where the risk resides. Okay, so if it can be, if there's a risk around some logic in a unit of code, it should be tested there. If there's a risk around the logic related how two pieces of code interact, it should be tested there. If there is a risk in the code related to how a piece of code integrates with a service or a library, that's an integration test. It should be tested there. We should not be testing these things at an end-to-end level. It means we can't get access to the right abstraction to test at the right levels. And if we can't get access and test at the right levels, then other modules or other pieces of software trying to use that functionality can't get access to it either. And it makes it more complex and more difficult, right? So a key lesson that I've learned over the years is, and it's good to listen to, is that if you've got lots of end-to-end tests, if it's really difficult to test, all those kinds of things, it's the architecture is the problem. It's not that you've got bad test automation. It's not that you've got bad testers. It's that the developers writing the code can't write the tests at the right levels of abstraction, meaning that they have to write all these horrible, clunky, slow, flaky end-to-end tests that end up costing everyone a lot of time and effort to maintain.
Yeah, and from my experience, I also faced with a lot of like testability problems. The most widespread problem that I see, especially in the web automation, is when we have like dynamic IDs for an element. So it is really hard or even impossible to write like really
Yeah.
stable end-to-end tests, or it is really hard to detect elements. And in that case, the I think the easiest way how we can deal with it and how we can increase the stability is just either to talk to developers to change something, to add ID for elements and to do something, or do it ourselves as a testers, because it's like why not adding some
I
simple stuff.
Again, I learned a critical lesson here, right? And it's so simple that it's almost too simple, which is when you get everyone involved in taking software from concept to customer together to talk about the pains that they've endured in that process of taking something from concept to customer, to discuss those pains and to share them, magic happens. When you get the ops person in a room with the developers talking about how difficult it is to build, deploy, and operate software in production, DevOps happens. The developers say, well, why are you doing that? We could write a script, we could do this. DevOps happens. When you get testers in the room with developers talking about how difficult it is to test, the developers will be like, well, why are you testing it that? Well, we have an API here that you could hit to do that. You're like, oh, I didn't realize. When you like, and the next, it's going to continue that way. So all these magical developments over the last 10, 15, 20 years in software have been when we get different people from the team together to have conversations about the friction and pain they encountered when they're trying to build, test, deploy, operate, maintain software, then magic happens, because the developers, who are creative problem solvers, much like the rest of us, go, oh, I could do something really quick and easy to make that much, 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 much easier. Before I had that experience, the 7 weeks of regression testing thing, I had this cool experience earlier in my career when I was only about 3 or 4 years into my career. And I was working with this small little team, about 5 of us. And it was a safety critical software application that ran on hardware. And the hardware was placed in manufacturing environments, and it looked at like conveyor belts for, say, like car manufacturing environments. And if somebody walked into an area that was dangerous, it would stop the conveyor. And if they stepped back, it would start again, right? So 3D visualization and all the stuff, life critical. So I was testing the software. The developer sat over here, and I was testing the software. But the problem I had was that it had a 2D view and a 3D view, and you could take snapshots to create planes and draw all these zones and all this crazy stuff, right? So you had a stop zone, which stopped the conveyor. You had a warning zone, which slowed it down. You get the idea, right? Mm-hmm. So I had to test all this stuff, but it was it was life critical stuff, right? The problem I had was, like, you go into a 2D view and you could do things, and then you take a snapshot, and then you go to 3D and you rotate, and then you click somewhere on the screen and it would just crash. And you're like, and this is the years and years ago, right? And you're like, shit. Because this was safety critical, life critical stuff. I knew I have to reproduce that thing. So I was like, what did I do? So I went in, I took a snapshot, I went to the 2D view, then I went to the 3D view, and then I rotated this way, then and then I clicked, and it wouldn't happen. And I'm like, oh, what was it? I forgot something. It was like that sensitive. It was that, it was like really, really sensitive. And it used to take me days, hours, days, sometimes weeks to reproduce these crashes, right? But I had to, because it was so important. And one day I was trying to reproduce one of these issues, and I went over to the developer, and I sat with him in his dev environment on his machine, and we were trying to reproduce it. And he turned to me and he said, do you know what we could do? We could just add a logging mechanism, so every time you interact with the UI, it actually just prints out what you did. And I just have a feature or a flag here in the background that you can turn on. And when we do that, it'll start logging everything. And I was like, okay, yeah, but how long is that going to take? He's like, half an hour. He's like, okay, I'll come back in So half an hour later, he added logging. He showed me how to do it. You just turn on this thing. And he said, cool, go away. And I started testing with it and crash. And then I went to the log, and it was like literally every single interaction is right there. Did a bug report, copy paste in the text, sent it to the developer. He can reproduce it in like 15 seconds. I'm like, fuck, I've
Yeah.
lost weeks and months of my life. You've just saved me so much time. It took him half an hour. It took him half an hour to put this in place. It was costing me hours, days, and weeks of time. And the only thing that happened was I shared my pain with the developer. We got together. He saw how difficult and how painful and time consuming this was. And he just used his ingenuity. So often you have testers experiencing pain and they just think this is normal. This is the way it has to be. But when you share that pain and you bring it to a developer, they see the possibilities. They can see like, well, maybe we can put an API in place so that it's really easy to tear down and set up this test. Maybe we can put logging in place so that you can reproduce this release. They see the possibilities, and there's this disproportionate relationship between the effort invested by the developer and the benefit to the tester. It's like half an hour saves me weeks of time.
Yeah.
It's crazy, right?
And actually, you point a good thing here that I see in many teams, in many organizations. They try to split the work of developer and tester and all of this role doing their work without any transparency to other roles. So without collaboration, without communication, and even on stand up, on daily scrums, or any kind of daily meetings, they just told, I'm doing like this, and maybe I have some problems or don't have some problems. So I see this as an issue. It's not, I think it's not about really testability, but sharing the knowledge, sharing what they're doing, making transparency to other people to know what are you doing, what areas are, what you struggle with, what you have the problem. Because it's easy to say that we share responsibility for the quality of our software and then just doing your job and not really care about the software quality. And okay, let's blame QA because they missed, because they working slowly, because they can't find any issues, because it's hard
Yeah,
to find issues.
exactly. But like the thing, so where I work, I've created a load of principles around software product development, and one of the most important principles is the team is the unit of delivery. We start together and we finish together. And by team, what I mean is a cross-functional team that has all the skills necessary to take something from concept to customer. And the idea of team and teammates is that you're there to support each other. You're there to help each other. You're there. It's not like your developers are over here and your testers. Like, we're a team. We're working together to take something from an idea and get it into the customer's hands and gather feedback as quickly and efficiently as we can do. So, and I often have this problem with testers. Actually, I have this conversation. I say, as a tester in a team, or as a developer in a team, or a designer in a team, or any role in a team, your job primarily is to make the team successful. So you want to optimize for, like, sometimes you have to compromise in things and help out with things that sometimes you don't like. Example being the developer is working away and the developer needs to code more things, right?
Yep.
In order to make the team successful, sometimes he has to stop the coding and he has to say, how can I make this more testable? And that investment in testability will have huge benefits for the team. It'll have huge benefits for the tester. Sometimes, like, a designer might have to, like, say, oh, this isn't the perfect design. I have to compromise on my design, but it means that we can get something quickly, cheaply into customers' hands to gather feedback.
Yep.
And that will make our team successful. It doesn't mean that I'm, as an individual, I've done the best design or whatever. So sometimes we have to compromise the needs of the individual to ensure that the team is successful. It's not about doing the best testing and find all the bugs and doing all the stuff. If that doesn't help the team succeed, that's pointless, right? So it's finding, how can I help as a tester in a team? How can I help my team and my teammates succeed? That's a really, really critical lesson that we talk about. And that the same goes for developers, the same goes for designers, the same goes for every role in the team. So you're there to help each other out,
Yep.
as best as possible.
Yeah, but the only, like, example also I can imagine in terms of, like, testability and how to help teams.
Mm-hmm.
Once in my career, I was involved in testing social casino games. It's just this, when you click a button and it just spins around and you get some like results, like slot machine.
Mm-hmm.
So and when I joined the team, I thought I saw that testers testing a lot of functionalities in it, and one of the functionalities was like the progress bar. So you need to spin one more time to see the progress bar is filling, and when it goes to, let's say, 100%, you get some prizes. And the the thing that I saw that to test this particular feature, tester needs to spin, like to click the button each time, like 100 times for each test. Like in the
Mm-hmm.
next regression, another 100 times. And then I talked to the developers and I asked, can we have, or maybe we can implement some API where we can provide some, let's say, state of the system that we can like change the state of the particular slot like on 99%, and after
Mm-hmm.
that the tester can test actual functionality, not just clicking around. And after we
Exactly.
implemented it like really improved or speeded up our testing, because it's
And
like,
you sped up your testing, but when you speed up testing, when you focus on testability like that, that means you can get more testing done in the same amount of
yes,
time. It means you can get more depth of testing. It means there's more likelihood of finding important bugs quickly, but also those weird ones that are hard to find, because you can now do crazy scenarios more interesting or more easily as well. Like I have a similar example in where I work, right? So I work for a software company that does software for the health industry, gyms and so on and so forth, right? A big thing for us is contracts and subscriptions and renewals. Imagine I'm a tester and I'm like, I have to test the monthly renewal. Okay, I'll just wait. I'll just wait a month. So what we have is we've got a time machine, a piece of software that's we call a time machine. So it allows us to speed up and slow down time. So when I say, oh, I'm going to create a monthly subscription and I want to check that once it goes to next month, they get a fresh set of credits or something like that. I don't have to wait a month. I don't want to have to wait an hour. So all I can do is I can say set system time to now, and then a millisecond later, fast forward a month and say, all right, and then observe what happens when the month turns over, and did I get the credits? Did I not get the credits? And when you think about it, right? So one of the models I have, one of the key ideas around testability is the idea of one, controllability, and two, observability. So controllability is our ability to control the environment in which you're testing. In this case, we're controlling time. So we can, because we've really high levels of controllability, we can control the system time really easily. Okay. And observability is the ease with which we can observe the things we need to see to determine is it working or not. So between being able to control our system and observe what happens, you have really, really, really good testability. So it's a simple idea is like, can I control the variables I need to influence the state of the software system I'm testing? And can I observe all the things I need to know to understand whether it's working the way I expect or not? So controllability and observability are the key components of testability. I also talk about two other ones, decomposability and simplicity, right? So decomposability is about how you can decompose it down into smaller and smaller parts, right? So when you talked about hitting a button there, my first thought is like, there should be a test there to see if the button works. That's isolating the risk there. Once I know the button works, I don't have to hit it 100 times to do that. That risk has already been mitigated by that test. So that you're decomposing your tests down into the smallest unit possible that lives closest to the risk. And so you're testing that the button press works, and then you might have an API it hits, and you're kind of going, okay, so the API probably talks to some components, and ultimately there's some unit of code that says if this greater than 100, then whatever. So that's where I should be testing that logic that you're talking about. At that level where the logic lives, where the risk resides. Not hitting the button 100 times. It doesn't make sense, because if the button works once, it'll probably work twice or three times before that. If the API works once, again, probably works. Yeah, so There's a risk that we have to test, is our API working? There's a risk that we have to test, is the button working? There's a risk that we have to test, does this component wire together and build deployed into the environment, does it work? Then there's this, does the functional unit, when it takes the input of 99, does it give me back false? When it takes 100, does it give me back false? When it gives me 101, does it give me back true? That should be tested down at the unit. That you shouldn't have to go through all those layers of abstraction to mitigate that risk, right? Makes sense? So that's decomposability. How easy is it to decompose the system into small independent parts that can be tested? And simplicity is this, how easy is it to understand what we're testing? You know, is there loads of different parts and pieces and stuff that I have to understand? So between controllability, observability, decomposability, and simplicity, which is the CODS model I talk about, we should have a really, really great understanding of how testable our software is. And that model applies to kind of software architecture. So remember I talked about the 10 Ps? That's the holistic testability stuff around an environment, is like, you know, the philosophy, the process, the people, the product, all that kind of good stuff. That talks about the big picture testability stuff. When you're talking about how testable our architecture is, I like to use that CODS model. You know, how controllable is the thing you're trying to test? How observable is it? How decomposable is it? And how simple is it?
If we are talking about the testability, and this is kind of degree, as you mentioned, right, that we can test. Maybe, is there any way to measure testability? Maybe there are connected metrics we can apply here.
Yes. So the metrics I use a lot, the key metrics around this stuff, really the DORA metrics are some good metrics around both testability and the operability, as I've described earlier. So the DORA metrics, for those who aren't familiar, are the accelerate metrics. There's 4 key metrics. Mm-hmm. There's 2 throughput metrics and 2 stability metrics. The throughput metrics are deployment, or cycle time and deployment frequency. Mm-hmm. How long does it take me from commit to the code is in production, deployed? And how often do I get my changes into production? And then the stability ones are related to change failure rate. How often do I have to act on a deployment because there's a problem that I need to solve? And mean time to recovery. How long does it take me once I've determined there's a problem to recover from that problem? And those metrics tell us a lot about not just testability, but operability as well, right? Because if we've really shitty testability, that's a technical term, shitty testability. I've coined that myself. If the testability is really crap, it's going to take you your cycle time is going to be quite long. So it's going to take you a long time to get the change from your mind into production, because it's like, oh, we have to build and deploy it into a test environment and manually test this thing and do this and do that and the other thing, right? It's going to take a long time, right? And you won't be able to, because it takes so long, you won't be able to deploy as frequently. And if testability is crappy, you're going to have more failures when you deploy. And it's going to take you longer to recover, because let's say you have an issue and you have to put a fix in place. You have to go away and you have to fix it. You have to do the retest. You have to put it through the pipelines. You have to get it in production. So testability is an enabler of those metrics. Operability too is an enabler of those 4 metrics. But they're the key metrics that allow you to know, am I able to get my changes quickly and safely into production? Now, you probably wanted some other metrics to do specifically to testing, right? But what I usually, but realistically, testing is just one part. Testing is one part of the transaction cost of change of software, and there's many parts, right? So again, when you think about holistic testability, it's even things like how the team works. Does it slice things down into small chunks? Does it use, do we work together to do, say, things like 3 amigas or 3 amigos to define the acceptance criteria together? All these things make things easier to test. All these things make, when you think, the most powerful thing for me actually is probably slicing. So when you can take something and slice it down into a tiny piece of work, the cognitive load associated with it, the size of the PR, the number of tests that you have to write at unit, integration, and end-to-end test level, the amount of exploratory testing and all that you have to do is far smaller. And the cognitive load, the number of permutations you have to consider, is smaller. So if you can get something super small, you can do a really, really good job of testing it in a relatively short period of time and get it into production with confidence. Yeah. Mm-hmm. When, however, somebody comes to me and they say, oh, my team, we work in 2-week chunks. We spend 2 weeks building something and then we start testing it. I'm like, fuck, that's going to be horrible. It's going to be terrible quality. My teams, when I work with my teams, I say a slice, which is something that we get into production, is a week or less. So it's a week or less of work. And when we have a slice, we break a slice down into stories. And a story is a day or two's work. And a story is something that works from pixel to persistence and back again. Mm-hmm. It's something that's testable. So that means that within a day, let's say we start work on a Monday, within a day or so, the tester is testing something. Right? It's not 2 weeks later the tester is testing. If it's 2 weeks later, the tester is finding 15, 20 different issues. And that creates so much stress and so many problems in the team because the developer's like, oh, that tester, stop finding bugs. And the tester's like, oh, there's so many bugs. And then the designer is like, oh, I didn't realize it did that. I didn't do a design for that, right? And everyone's just pissed off and annoyed. If you slice it down into less than a week and you break it, the slice down into stories of a day or so, then, as I said, the developer is like, oh, it's super small, it's super simple, it's too simple. I'm like, no, it's not too simple. Just build a thing. It's very, very simple. You do your 3 amigos, you agree it. And it's like, okay, this is the simplest thing in the world. It's basically a button. When I click a button, something happens. Like, it's too small. I'm like, nope. Because then the tester says in the 3 amigos, what happens if you hit escape? What happens if you do this? What happens? You go, oh, didn't think of that. Okay, right. Write the acceptance criteria, code it that way, super simple. And then you test it, and you can test it in 10 or 20 minutes. And maybe you find something, maybe you don't. And then the next day you're doing the same, and the next day, and the next day. And after a week, you've tested everything individually, and you can roll it together into the slice and test it holistically. And usually you find very few things at that point. Now, What we do is we break it into stories. We pair with the developers. So the tester and the developer, we do the 3 amigos and all that crap. Then we pair with the developers, both on the test automation and the exploratory testing. We go through each of the stories, and then at the end of the week, we do a team bug bash or team exploratory session. So the whole team, the developers, testers, designers, PM, all that get together in a room for 45 minutes, and they test the slice together. And the whole team goes, yep, we're ready to deploy it. And then what we do is we deploy it behind a feature flag into production. We toggle it on for some test users. We make sure it's working with the test users. And then we toggle it on for a customer. And we have instrumentation and observability in place so that we can see as the customer is using it. We check for errors. We do all that stuff. And we slowly roll it out to customers, gathering both qualitative and quantitative feedback from our customers. So we're gathering the data about the usage from the quantitative, and we're talking to the customers to get feedback, qualitative feedback. Does that make sense? So again, we're mitigating risk. We're testing well. We're slicing it super small, and then we're drip feeding it into the customer's hands to manage the impact if there are issues. And once we build confidence over a day, a week, whatever, then we can start releasing to more and more people. We have the observability and all that stuff in place so that we can see if there's any issues emerging.
Yep. And actually, what you're telling right now, it's looks for me like kind of mob programming, when the whole team works on the same piece of work and go to designing stage when the idea arrives to deployment and production, verifying this on production.
Yep. That's what we try and do. We try and work together as closely. As I said, the team is the unit of delivery. We start together, we finish together. So we talk, when in GlowFox, we take on problems together as a team. We say, okay, what's the problem we're trying to solve here? We understand the problem deeply. As a tester, as a developer, as a designer, we get to ask questions and probe and say, oh yeah, what about this case? And what about that case? And what about, we have a common understanding of the problem. And then we slice it down super small together. Everyone's involved in the slicing decision, the tester and everyone. Okay, take your input there. And then once we have the slice, we break down the stories together. And then we do the 3 amigos or the 3 amigas together, designer, developer, tester, or product developer, tester. The developer usually does the development. Sometimes they're pairing, sometimes they're mobbing, sometimes they do it on their own. And then we usually pair to test. We might pair to do the test automation, depending. Again, the testing and test automation is more of a responsibility of the team than the tester. The tester will often guide or pair or do stuff like that, because if you've got like 4 devs in the team and you've got 1 tester, they can't scale to to test and write the test automation for all the things the team are producing. So they become the bottleneck. So the key there is to say you pull the tester out of doing all the testing activities, and you're very selective about what the tester does. They pair a lot with the developers to do testing. They pair a lot with the developers to write the test automation. They guide the testing. And sometimes there's specific things that the tester will test because it's complex or whatever. But most of the time in our more mature teams, it's the tester guiding the testing activities of the team, setting up the bug bash, going to Tree Amigos. The Tree Amigos thing is great for prevention of problems anyway. And what happens as you cycle through those slices week by week by week, the developers become better and better at testing. They become better and better at doing Tree Amigos. They get better and better at writing the test automation. They get better and better at doing exploratory testing. They get better at everything. And all of a sudden your tester's like, what am I going to do now? Oh, this is interesting. So they have to stand up with them to say, oh, security. We haven't done much in security. We should do some security testing, and we should improve the pipeline, or we should do whatever, right? But, having a tester as a bottleneck in your team where you have 4 developers producing shit tons of code and you have 1 tester trying to keep up with it and write test automation, like that's another thing I have a big problem with, is when you have you've got like great developers on your team, and then you ask your tester to write like test automation, which is coding. You're going, why are you not having the coders that write lots of code every day? Why aren't they writing the code? Because when they write the test code, they see the opportunities for testability improvements as well. Yep. So if you have your testers over here writing test automation in isolation, they don't know what's possible in the code base. Right? They just feel the pain of writing test automation. If you have your developers that need to maintain, extend, and write your test automation, then they're kind of going, oh, we could put an API here, and if I hit that, I can clear this down or do a tear down, or I can, do a setup, or I can do whatever needs to be done, right? So it just becomes more natural. So there's a book by a guy called Nassim Taleb. It's called Skin in the Game. And the key idea from Skin in the Game is that you need to connect your choices with the consequences of your choices. When it comes to testing and testability, often the developers are not feeling the pain of their choices. The tester does. And that creates a poor relationship, right? So what you want to do is you want to connect the people making the choices about the architecture and the design, the developers. You want to connect them with the consequences of their choices, the pain of testing. And when they feel and see the pain of testing, they'll make better choices. It's a bit like on call, right? Yep. So if you put your developers on call and they find it really, the system starts going down and there's no logs there to debug, and they're like, they come in the next day and go, fuck this, I'm going to improving this code. I'm going to adding logging. I'm going to, because they felt the pain themselves. Whereas if it's the ops people just have to deal with the pain, and the developers are sleeping at home and they're happy, right? So consequences of your choices being connected to your choices are really, really, really important. I think the classic example was the aeronautical engineers who were asked to fly in the first flight of a plane. So you're going to do a pretty good job of designing a plane if you're the first passengers. Otherwise, you pay fairly heavy consequences, right? So you get the idea.
Is it really, like, from my perspective, like, testability is really interesting topic, and there are a lot of improvement that even one tester can do in a team. But for me, it is interesting. So when you are, for example, when you are engineering manager or development manager, or even someone higher, you have this, and you have understanding of testability. You have all of the, let's say, all of the possibilities to change something. To change, for example, hey, developers, let's do like code automation tests. Hey, developers, let's do operations, because you have an ability to change process or to offer things and to gather everybody to do something. But my question is, when you are just a tester in a team, for example, you are joining new team or you're just joining your existing team. So what are the first steps that you can do when you are, let's say, joining new team as a tester, that you can identify testability problems and offer at least few first steps to improve?
Okay, perfect. There's 3 things I would suggest you do. Let me write them down for myself before I forget them. Okay. The first is build relationships with the developers. The second is to track your testability problems, and I'll go into depth in each of these. And the third one is to use postmortems to drive change. Okay.
Mhm.
So, first one, right? So, if I went into a brand new team as a tester, the first thing I would do for various reasons is build relationships with the developers, is get to know the developers, is like build a sense of trust. Because once you have a relationship with developers, you can start talking to them about challenges and problems. You can start saying to them, "What's the biggest pain and what's the biggest challenge for you in development?" It's like, "Oh, like it's like they'll be like, it takes me so long to, like writing to unit tests is a pain in my ass. I can't think of the ideas." And you're like, "Oh, I've got this handy heuristic here, right? That you could use, right? You know, that
Mhm.
might help you generate unit tests. Or if you want it, next time you're writing some, just bring me over and we'll pair and I'll give you some ideas." All that kind of good stuff, right? So, like, for me, one of the key things that I did when I was a tester was build really great relationships with the developers, get to know them, be of use to them. And like, there's one thing that drives me crazy is like the testers that are like, "Oh, I hate developers," right? I love developers, right? And what I also focus on is making sure that I'm not just going to developers when I need something, when I have a problem. If the only time I go over to a developer is to say there's a bug there, that relationship isn't great. So I try and go over and build a relationship and be of use and help the developers and create that relationship where they know we're working together to try and create a successful product. And then when we do find bugs, it's like, oh, they're more open to it. You can have a chat. And then like they could say, oh yeah, maybe next time, maybe just come over to my machine when I have something new and we'll pair on it. We'll test it together. Brilliant. Yeah, let's do that. That's really, really cool, right? So that's the relationship part. Once you have the relationship, you can have those conversations. You can make the suggestions. You can bring them and get them pairing with you on testing, and you can pair with them. And all of a sudden, it's like, oh yeah, if we made this change, maybe we could do this, and all those things naturally happen, right? But relationships are the foundation, right? Another exercise that I do is while I'm testing, like I used to literally track the things that annoyed me, that slowed me down, that made testing difficult. So I'd literally have stickies or make notes, and I'd literally go, okay, so it took me 20 minutes to do the test setup for this test because I had to do this manually and I had to do this thing. And as I worked, the things that took the most time and were the most painful, I'd literally put them on stickies. And I might even say, oh yeah, I had to do that 3 times and it took me an hour. So that's like 3 hours I wasted there. And bringing that data and capturing that stuff and then analyzing it yourself and saying, I'm wasting so much time on this setup. I can't even test this thing. It's impossible to test for these reasons. So there's this, what makes things slow, what makes things difficult to test, and what makes things impossible to test. That's what I kind of track. And then once I track those on stickies or keep my notes or whatever, at the end, let's say it's the end of the slice or we're doing a retro as a team, I can bring that data, that context to the team and go, it's taken me a lot of time to do this. Is there anything we could do? Because it would save me 6-7 hours a week or whatever it happens to be, So it's gathering the data and the evidence to understand where the pain points are, what the problems are, or I couldn't test this thing at all because it's impossible to get it in this state. Is there a way that we could do something to allow us to test that, right? And the developers might go, oh yeah, we could create an API to simulate that or whatever it is, right? So tracking the things that make testing difficult, the things that make testing slow, the things that make testing impossible on stickies and like the impact of those things and sharing them with the team is a good exercise. And then the last one is postmortems, or whenever there's a problem, an incident in production, an escape defect or any of that thing, that's a brilliant time to talk about testability because people are feeling the pain of having something go. It's usually kind of stressful and people are like, oh shit, we made a mistake, blah, 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 blah. That's a perfect time to say, is there something we could change here to actually improve the experience? It's like, if I have another exercise I do where you systematically go through the experience in terms of what was it like in terms of the detection of this issue. Did our customers find it, or did we find it? It's like our customers found it. Well, that's a bad experience. Maybe we could have put some some monitoring in production for this particular thing. What was it like in terms of, identifying the root cause of the issue? What was it like retesting the issue? What was it like, repairing the data associated? So we systematically go through all those steps and try and take the various lessons out of it. And what was the experience like trying to prevent this issue? It's like, okay, so we didn't have any test automation here. We were under time pressures. We were doing this. Okay, there's interesting things to learn there. Maybe we need to reduce the pressure, take more time, slice things smaller, work together to write the right test automation, fix the problems with the test automation because those tests actually failed, so it shouldn't have actually been released. But they always fail, so we ignore them, or some stupid thing like that, right? I don't know. But the postmortems are a great opportunity to bring up the problems and the challenges when people have an appetite to change. And just, as I said, if you bring all the testability challenges into the postmortem or a retrospective as a team, they help as well and say, well, listen, I was under so much pressure to test this. I didn't have enough time because it took me 7 hours to do the test setup here. It took me blah, 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 blah. Is there something we could do as a team so that we could reduce that, so that I have more time, so that I can test deeper and faster and all those kinds of good things?
Yeah. And actually, your story reminded me of a lot of problem that I saw in many companies. It's not about new joiners. When you new QA and you join the team and you start finding a lot of things that's annoying, that slows you down, that you can do, and you need to prepare a lot of things. But in many situations, when you start talking about this is slow, this is not working properly, I have the same answer from the team or from the QA that stays for a long time in the team. Historically, this is historically like this, so we are.
It's always been this bad.
Yeah. I mean, and for them, they cannot see this kind of issue that because they already agreed with this, that they need to do like many steps before they start actually testing or deep dive into technology or deep dive in architecture stuff and make really thorough testing. So, and really it's good. And actually for some of my students, I'm telling them how you can improve your testing. Just figure out what's annoying you, what are you doing, and you like hate. This is the point for improvements. This is how you can change the things here.
Yep. It's you're looking for friction. It's essentially it. What slows you down, what makes it more difficult, or what makes it impossible. It's the friction, and it's, as I said, that friction is a signal that you have a testability problem. So pay attention to those signals, and as I said, those points of friction are what's slowing you down in terms of getting feedback as well. So coming back to the DORA metrics, if you want to be able, so we do about 30 deployments a day, 30 or so deployments a day, right? So if you think about how quickly and easily and small each of our changes has to be to allow that. So we have, our changes are super, super small. They're always released behind your feature flag. They always go through the pipeline. We religiously maintain our pipeline so that we ensure that if it fails, that we actually act on the pipeline. We try to address any failures, whether it's a genuine failure and it's a bug, whether it's a failure related to the test automation or it's a failure related to infrastructure. We need to act on those things, right? We need to ensure that the health of our pipeline is the first and foremost priority. Because if we need to get changes into production and we have unreliable health pipeline, then we don't know the health of that change. We don't know what we're putting into production. So the health of the pipeline has to be more important than getting new shit into production, right? So we have to prioritize that stuff. So super small changes, very reliable pipelines. We, as I said, we have small changes. We test, we pair on the testing. We keep them small so it's quick, and we get those changes into production quickly behind a feature flag. Then we flick them on for small customers. We have great observability and instrumentation, so we can see once they come on, are they creating issues? Are they being used by customers and all that kind of good stuff? And then we gradually roll them out. But there's a lot of rigor and a lot of, like, if you're deploying 30 times a day or more, or whatever it is, you need to have all that stuff super, super friction free. You know what I mean? It needs to be super smooth. The testing has to be quick. The size of slices have to be small. The feature flags have to be, easy to do. The pipelines have to be great. The build, deploy, the observability has to be, all that stuff has to be great. And the way the teams work together to do that has to be great.
Yep.
So you need to identify a friction in terms of getting something from concept in your mind into the customer's hands. Any point of friction there, whether it's to do with testing, whether it's to do with deploying, whether any of that stuff, is an obstacle to learning. And learning is what software is all about, right?
Yep.
So software isn't about building things. People think it's about building things. It's not about building things. It's about learning. So we get software into production, get it into customers' hands so we can learn what they want and what they don't want. 80% of everything we build is waste in software industry. 80% of software is not used, has no positive impact. Just 20% has a positive impact. All right. Yep. So most of the stuff we build is complete waste. So that's depressing. So one thing to take away from this as well is stop just building things and start, as testers, start questioning, why are we building this thing? Where is the evidence that this thing is valuable? What's the smallest thing we could get into our customers' hands that validates or invalidates that this, one, solves the problem for the customer? Okay, so one is the right problem, and two is the right solution to the right problem. Okay, So you could spend your life testing the most perfect software that nobody uses. And many, many people spend hours and days and weeks, and I've done this in my career, testing a piece of software that nobody uses and has zero value. So that's another challenge for some testers, is to think about this, is like, how can we test if this software is actually valuable? Not that it can do the thing we think it should do, but that it actually helps real people and customers solve real problems in their lives.
Yep.
As I said, the trick is to get things into customers' hands as quickly and cheaply as possible and gather data from them. And most of the time you'll be wrong. And if you can do that in less than a week and find out that you're wrong, but that what about what you did was wrong. It was wrong because it doesn't do this or it does do that or whatever it is, then you can adapt and change based on feedback. And that's what gives us great companies like Amazon, who in 2014 did 1 million deployments, right? So Amazon, 1 million deployments in 2014. I don't know how many they're doing today. So every deployment Amazon does is an opportunity for them to learn about their code, to learn about their infrastructure, but most importantly, to learn about their customers, to learn about what they want and what they don't want. So they're a learning engine. They're an experimentation engine. And they know that most ideas are shitty. So they say, if 1 in 20 ideas is successful, if I can do 1 million deployments, then chances are I'm going to hit on some pretty good ideas, right?
Yep.
Pretty quickly. Whereas if I'm a company that's saying, oh, I'm going to do quarterly releases, or I'm going to do monthly releases or bi-weekly releases, what's the likelihood that one of those ideas is going to be a good idea? If it's 1 in 20 or whatever it is for really good ideas, then it's pretty unlikely that you're going to actually build something that's really valuable, right?
Yep.
So anyway, I've gone off on the tangent completely away from testability, but it's testing in a different light, right? It's like what's wonderful about testers is they got this critical thinking mindset, and when we apply it broader than just the software and the functionality, and we start thinking about how can we test this idea? How can we test if this is the real problem people want to solve? How can we test if this solution solves that real problem? That gets really, really, really interesting, as I said, because if you're solving the wrong problem in the right way, you can test it. It can be scalable and secure and performant, but nobody uses it. Have you done a good job as a tester? But this is the thing. It does, like, would you rather have a buggy piece of software that is used by lots of people, or a perfect piece of software that's used by nobody?
Yeah, the first one, I think, but yeah, if it's not a mission critical software.
Well, it can't be too mission critical if nobody's using it. It's so mission critical we can't use it.
I think
No, but I get your point, right? It could be something like some kind of failback mechanism that's very rarely used, right? Yep. So only in exceptional circumstances. But in general, if you're building software, I'd much rather to build shitty software that people find valuable, because you can learn and you can iterate and you can make it better. Whereas if you spend like a lot of time building something that's perfectly formed and functionally beautiful and perform, and nobody uses it, how do you fix that? That's a foundational problem there. So there's a weird balancing act there for testers around figuring out, are we solving testing for whether we're solving the right problem, and then when we do find a problem we're solving, make sure that we're solving it well. So yep. It's an interesting one.
Okay, I think we need to wrap up, but what we forget before wrap up, Oleksandr?
We forget, first of all, to thank to all of the listeners that listen to our podcast. And if they want, they can comment what they or how they understand testability in the comments below. And also to just click the subscribe button if you have not done it before. And also, we want to thank Rob for having so like I don't know how how it's called, but beautiful conversations. We had a lot of insights, and the last questions that I have in my mind is, when I started to dig into testability, it was really lack of resources, lack of books, articles, or whatever on testability, because it is like a thing that everybody understood, but nobody has written about it. And the only book that I found, it was like Team Guide to Testability. That was only the book that I found. Yeah. And I read it, and that was the first book that I actually read, and I understood testability from different angles. Not just like, it is how easy to test, and that's all. Because it's like in many let's say, even in ISTQB or other certifications, it's just a one-liner. Mm-hmm. It's how easy to test, but what it is, I don't know. So what other resources can you recommend?
On testability, as I said, there's some nice stuff written by, and there's a great talk by a guy called Michael Feathers on the relationship between testability and great design. It's on YouTube. For those that are interested in kind of the relationship between, as I said, how testable it is they typically think about it from a test automation perspective or a unit test perspective, and great software design. Again, Dave Farley talks a lot about it as well. He's talked about stuff like the time machine or time warp stuff that I described as well. Let me think. Like, there's some, like, in fairness, there's some great stuff from the likes of James Bach and Michael Bolton from back in the day as well. They write a lot about that stuff as well. Mm-hmm. What else? Yeah, like, as I said, there was, I think, was it Maria Kondo as well? But yeah, those, like, as I said, Michael Feathers, Dave Farley. Oh, there's some other good stuff by Aslak Helsoy as well, who was the guy behind Cucumber. So he talks a lot about like the software architecture and running acceptance tests in milliseconds, and the guy called Nate Price as well. So Dave Farley, Michael Feathers, Aslak Helsoy, and Nate Price have really good stuff. Good stuff around this. And one last guy is what's his name again? JB Rainsberger. He has a good talk called Integrated Tests Are a Scam. So it's a pretty cool talk if you've never seen it. It's around clean architecture or hexagonal architecture. So
Mm-hmm.
all those 5 guys that I talked about talk about kind of testability from a software architectural perspective. If you want to learn more about the kind of the general testability stuff, I think Bach, James Bach and Michael Bolton have some nice stuff there as well. But yeah, other than that, I'm sure there is, as you said, it's not easy to find the stuff. So yeah, and there's another guy called Bob Binder or Robert Binder that did some good stuff too. But yeah, hopefully that's enough to keep you going
Yeah.
for a little while.
Yeah. Yeah, totally. I think that's all for this episode. Thanks a lot for being with us and for talking about the stability. And yeah, see you at the next episodes. And yeah, I think we have a lot to talk about. And one thing that I learned, we need to talk about observability.
Observability, operability as well. So
Operability, yeah.
operability is the superset of observability and the ability to control risk in production. So observability is to be able to see it, but then you also need to be able to control risk. So using things like feature flags, using things like blue green deploys, anyway, I could talk all day about that stuff as well. I won't bore you. We'll never get to finish the podcast if you get me going about operability. But operability, as I said, testability and operability are best friends. Testability minimizes the likelihood of introducing defects. Operability allows you to minimize the impact of defects when they do occur. So the two testability and operability allow you to manage risk really effectively in software product development.
Amazing.
Good. Yeah.
Okay,
that's
guys,
great.
that's it, and see you in the next episodes.
Thank
Bye.
you so much.